All right, welcome to notes. The very last thing we're doing for this year. This will be in going for a quiz. It's not a full unit. It is SOHCAHTOA. It is a kind of continuation from your geometry from the year before. Pretty easy, especially the second time through. Try to make it really easy for you. This is notes for Monday. May 1st. It is senior night for my 4 seniors for softball. Please tell them congratulations. But it is senior night for me. So here we go. Let's get started. All right. As I look at this, we're going to talk about SOHCAHTOA. SOHCAHTOA refers to right triangles, okay? So that's the first thing we're dealing with. We're dealing with nothing but right triangles. And as I look at this, we have some vocab. Want you to look that over. It says right triangle is a triangle with 1 right angle, 2 acute angles, also has 1 hypotenuse and 2 legs. You can see that right up here. The hypotenuse is always the hypotenuse. I refer to the longest leg as the long leg, and then I refer to the short leg as the small leg. Kind of helps as we move forward with this. Obviously, our right angle is indicated by a box, as it tells us the opposite, the side directly across from the angle. So if I'm looking at an angle, like the side directly across from the right angle is the hypotenuse. If I was talking about this angle right here, this small leg is the side opposite of this angle that I just drew the black circle in for. Adjacent the side next to or touching that angle. The long leg would be the side that is adjacent to this angle. This would be the long leg. It is touching my angle that I drew with the black circle. That is called adjacent side. All right? And then obviously the hypotenuse is always the diagonal side across from the right angle. Okay? Always across from the right angle. That's what I need you to remember. All right, so let's take a look at this. Practice with opposite, adjacent, and hypotenuse. The opposite side. Well, where does it want me the opposite side from? Well, it tells me up here from angle T. So the opposite side from angle T. Well, where's angle T? Well, angle T is right here. So what is the opposite side? Well, the opposite side is this side right here. Well, what is that? Well, that is side VU. What about adjacent? What would be adjacent to angle T? Well, angle T is right here as we see, so the adjacent side would be side TU. And the hypotenuse? Well, the hypotenuse is always the hypotenuse. Remember that. The hypotenuse is always the hypotenuse. That is going to be, what is that? VT. Now notice that I've drawn a line segment above that because these are line segments, right? They're not going forever and ever. They have very fine endpoints, right? So they have endpoints that is a line segment. As I look at this, let's do the next one. From angle V. From angle V. What is the opposite side? Well, from angle V, which I'm going to do in blue, is this one right here. Well, the opposite side. Well, that is over here. Opposite of that angle is all the way over here. So that is side T and U. The adjacent side next to it is going to be this one right here. So it is VU. And the hypotenuse will still the hypotenuse. That is VT. Now if you'll notice something, the opposite side for angle T was VU, but the adjacent for angle V is VU. Well, that does make sense, right? If it's opposite of one, it's got to be adjacent to the other. Okay, so we're going to keep that in mind. All right, and now to the crux of this, the SO, the CA, and the TOA. Here we go. Sine equals opposite over hypotenuse. You'll see people write this as SO. And literally what that means is sine of the angle, the sine of that angle is equal to its opposite side over the hypotenuse. Cosine of that angle is adjacent over hypotenuse. We say ka. And then last but not least, tangent of the angle is equal to the opposite over adjacent. We say toa. So, ka, and toa. One of the biggest things, one of the kind of things we do for test prep, getting ready for ACT, is we tell people, write SOHCAHTOA at the top of the ACT so you remember how to do it. All right? This is a big concept. All right, so let's find some different points or different ideas looking at a triangle. All of this can be found by looking at this, and we're simply going to match. Opposite leg to angle A. Opposite leg to angle A. Well, angle A is right here. Opposite leg to angle A is BC. Where is BC? That is 5. Sine ratio of angle C. The sine ratio of angle C. Well, isn't that so? Right? So that's going to be opposite over hypotenuse. Well, angle C is right here. So if I want opposite over hypotenuse, it's going to be AB over AC. Well, if I find that, where's AB over AC? Number 8. Good. How about opposite angle to AB? Opposite angle to line segment AB. Well, opposite angle to AB is angle C. That should be 3. How about the hypotenuse? Well, the hypotenuse is always the hypotenuse. That's AC. That should be 6. Adjacent leg to angle A. Adjacent angle. Well, angle A is right here. Adjacent would be AB. AB. That should be number 4. Now, you may ask yourself, well, the hypotenuse is adjacent to that angle as well. Correct, it is. But the hypotenuse is always the hypotenuse. When we're referring to opposites and adjacents, we're always talking about the long leg or the small leg. The hypotenuse is always the hypotenuse. All right, number F, tangent ratio of C. Tangent ratio of C. Well, I know that that is TOA. So if I'm looking at C, that is opposite over adjacent. Opposite over adjacent. Well, what value would that be? AB over BC. AB over BC. That is 10. Very good. Hey, reference angle of BC over AC is the cosine. Well, cosine is ka. So I need adjacent over hypotenuse. Adjacent over hypotenuse. What are we going to refer to? When you think about it for a second. I agree. It should be number 3. It should be angle C. It should be angle C. Adjacent would be this one right here, right? So that's BC over AC, which is the hypotenuse. AC is the hypotenuse. That's hypotenuse. That's 3. Adjacent leg to angle C. Adjacent leg to angle C. Angle C, adjacent leg is BC. That's 5. How about cosine ratio of angle A? Well, cosine is ka. So I want adjacent to angle A. Adjacent. AB. Hypotenuse. AC. Well, which one is that? Well, I should be number 8. You're going, wait a second, we've already used that. We have, but it's okay, we can use it twice. The longest side. Well, what is the longest side? Not the long leg, but the longest side. It's the hypotenuse. It's the hypotenuse. That should be 6. And then last but not least, the reference angle, if BC is the sine ratio with sine, is so. So I want opposite over adjacent. Opposite over adjacent. If BC is the opposite, it's got to be angle A, which is number 1. All right. Hopefully this makes sense to you. Hopefully I'm not going too fast for you. Make sure you can pause this at any time. Some of this you should be able to do really quickly in your head anyway. All right, let's move on. Use your calculator to find the following trig ratios, and we want to round to the 4th decimal. Round to the 4th decimal. Well, this should be easy. I've got my calculator. See, we got our calculator. Now the first thing we're going to do is tangent of 78 degrees. So in my calculator, I'm going to hit tangent. I'm going to hit 78. I'm going to close the parentheses just because I like to close the parentheses. And I'm going to hit enter. Well, I've got, where did I get? Not the correct answer. I got a negative. Let's see what I did wrong. You know what's wrong? My calculator is in radians and not degrees. Good catch by me. Make sure that we put our calculators into degrees. That's one of the big keys that we have to do. Make sure our calculators are in degrees. Now put tangent of 78. Much, much better. It comes out to be 4.7. 4.7046. 4.7046. I rounded it to the 4th decimal. After the 6, there would have been a 3, so I don't need to raise it up. 1, 2, 3, 4. I've got it. How about tangent of 80 over 18? Tangent 80 divided by 18. Close my parentheses. Should be 0.077772. So 0.0777. All right. How about the next one? Tangent of 23 degrees. You should get 0.4245. Sine of 90 degrees. Sine 90. 1. Now, if I said the 4th decimal, that would be just 4 zeros behind it, right? A whole number, just took it to 0 right behind it. How about cosine of 15 degrees? 0.965 and 9. Sine of 4/3 is 0.0233. And cosine of 5/16. Well, you're going to get this. What does that end up being? Right there. 0.9999 rounded up, right? Round should be 1.0. All right. Hopefully you did this along with me. Know how to do it. Easy enough, right? Putting it in the calculator. All right. Let's move it on. Use the tangent ratio to find the value of the variables. Leave answers in exact form when possible, or round to the nearest tenth. So here we go. We want to find the value of the variables. I want to find x. Well, I'm given an angle here, and I'm given a side. I'll box 1 and circle 1. So what do I want to do? Well, if my angle is here, this x is on the opposite side, so I've got an opposite. This is adjacent. Well, what is the only one of our trig ratios, SOHCAHTOA or TOA, that has an O and A? That's right, TOA. So I am going to do tangent of 56 degrees is equal to opposite x over 13. That is my ratio. That is TOA right there. So now I just got to solve for x. So here we go. I see a denominator. I want the x by itself, and I see a denominator, which means I need to multiply both sides by that denominator. So when I do that, I'm going to end up with 13 times tangent of 56 degrees is equal to, these 13's cancel out, leaving me just x. Well, 13 times tangent 56 can go into a calculator. Here we go. 13 tangent 56 gives me 19.27. So x is equal to 19.27. Well, it said round to the nearest tenth, so I'm going to say x is equal to 19.3. All right, here we go again. Here I go again on my own. Someone can find that song. Might give you some extra credit. Here we go. I have an angle, 32 degrees. I have an opposite side, 11, so I have an opposite. I have adjacent. Well, once again, what do I have? I have TOA. So I'm going to have tangent of 32 degrees equals opposite 11 over x. So here we go. I got to solve for x. Well, this one's a little bit different. I've got the x on the bottom. Well, it's still treated the same way. The same way we did this, we had to do here. My common denominator is what? X. So I'm going to multiply by x, and I'm going to multiply by x. So this gives me x times tangent of 32 degrees equals, the x is crossed out over here, giving me 11. Well, you're saying, wait a second, you crossed out an x. I did, but I still have one. And I still need one, and I only need one, right? I don't want two of them at this point. I want one because my power is a 1, right? So I need one answer. Well, how do I get rid of tangent 32 degrees and get this x by itself? Because it's multiplied by this x. That's right, we're going to divide. We're going to divide by tangent of 32 degrees to both sides. Because remember, what I do to one side of an equation, I must do to the other. So here we go. When I do that, these tangent of 32's cross out, leaving me just x, and the x is equal to 11 divided by tangent of 32 degrees. Well, I can put that in the calculator, can I? 11 divided by tangent of 32. Well, it gives me a nice number. Gives me 17.6. Well, that's what I'm looking for right there. So remember, if my x is on top, I'm going to multiply by the common denominator. If my x is on the bottom, I'm still going to do the same thing. I'm just going to have to make another step and do divide by the tangent to get it over to the other side. Reality is that this is just one more step than this, but it's treated the same way and it's done the same way. All right? Here we go. Let's move on. Use sine and cosine trigonometric ratios to find the values of the variables. Leave answers in exact form when possible. Round to the nearest tenth. Once again, we're going to round to the nearest tenth. We're going to go blue this time. So, wait a second here. I've got an angle right here is 33 degrees. I see that. But I notice I got a y, and I'm going to make this one a kind of an oblong shape, a triangle almost, and an x. I've got two variables. Well, I can't solve for both of them at the same time, but I surely can solve for one at a time, right? Solve for one, then solve for the other, okay? So as I look at this, I want to solve for x first. I'm going to say that's my first job. And then my second one is I'm going to solve for y. So I'm going to do two problems here, okay? First one, solve for x. Well, if I have 33 degrees here, and my x, and it's right here at this angle, my x is opposite of that. So I've got an opposite. Well, y is adjacent, but I can't do x and y at the same time. But look, I've got an hypotenuse. Hypotenuse. So I've got an h. Well, what's the only trigonometric ratio between SOHCAHTOA and TOA that has an H and an O? That's right, it's SO. So I'm going to use the sign. I'm going to use SO. So sine of 33 degrees is equal to opposite x over hypotenuse, 15. 9, just solve and go. Solve for x. Well, once again, I'm going to multiply by both sides by 15. So that gives me 15 times sine of 33 degrees is equal to x. So x is going to be equal to, what is that? Well, that's going to be 8.2 in my calculator. 8.2. Well, it's partially done. I've got x. I've got x is equal to 8.2, so I know that this is 8.2. Now I want y. Well, how am I going to do y? Well, let's see. I want y, which means I've got adjacent to 33, adjacent. And I have hypotenuse again, so I have this. Well, a and h. That's right. That's a ka. So we're going to do cosine this time. So cosine of 33 degrees is equal to adjacent y over hypotenuse 15. Done exactly the same way. Look, everything is going to match. It's all set up. Multiply it by both sides by 15 to get rid of it. And that means get rid of the common denominator. So 15 times cosine of 33 degrees is equal to, the 15's cancel out, leaving me just y. And y is going to be equal to 15 cosine of 33 is 12.6. 12.6. Okay, good. Hopefully you're understanding. We're about 21 minutes in. We got one more to do and we're all done for this. Okay? Let's go to green. In this one, I have 48 degrees right here. I've got a B and I've got an A. Right there. Well, I want to solve for each one of these. I want to solve for A. And I want to solve for B. I'm going to create some space for me. I'm going to go ahead and erase this. Everybody should be caught up. If not, should have paused it by now, gotten through it. Here we go. Giving me some space. The Final Frontier. These are the voyages of the Starship Enterprise. Hopefully you know what show that is. All right. Here we go. Well, I've got 48 if I want A. Well, what is A? Well, A is the hypotenuse. Well, if I want A, which one can I do? Well, I could do, up there, but I don't like it. That's opposite, right? So I don't want to do so. That's opposite. How about this? How about adjacent? Could I not do adjacent and do cosine of 48 is adjacent over the hypotenuse? That's the one I want to do. I don't want to do opposite over the hypotenuse because they're both variables. So I'm using cosine of 48 degrees is equal to the adjacent, which is 10, over my hypotenuse, which is A. So here we go. Multiply both sides by A, which is my common denominator. So I have A times cosine of 48 degrees is equal to, these A's cancel out, the whole reason why I'm doing it, by 10. Divide by cosine of 48 degrees. Divide. What I do to one side, I must do to the other. So A is going to be equal to 10 divided by cosine of 48 should be 14.9, 14.94, roughly 14.95. So you could round up to basically 15. Okay, as you round it up. All right. Last but not least, we need to find B. Well, B. Well, I've got opposite of 48, so I've got an opposite over here. I've got an opposite. Well, I know A now. I know A is 15, so I could use opposite over hypotenuse. So I can do that, so I can do so. So here we go. Sine of 48 degrees is equal to opposite B over my hypotenuse, which is 15. Multiply both sides by 15. I get 15 times sine of 48. Bad looking in there. Let's got to make that a little bit better. 15's crossed out, leaving me B. So now, B is going to be equal to, putting it into the calculator, should be, let's do it, 15 sine of 48, 11.15, so 11.2. 11.2 would be my answer. All right. You're having the full, I've given you a packet. It does have your review for the final in the packet. It's in the back side of it. So you can start on that at any point. You also are going to get your note sheets for the final. I'm giving you that today as well. So on Monday, I'm giving you the note sheet for finals. You are given this packet, which will have your final review in it as well. And then 12.1a is your homework for Monday. Now, our daily practice, because you should be able to finish it in class, okay? So all I want you to do is the odds or the evens. It does not matter which ones you do, odds or evens. I'll have the answers for both for you. Odds or the evens. All right. Have a good Monday. See you on Tuesday. I have no game on Tuesday, so I will be in class. We'll talk to you.